Friends, here we have to find the coefficient of x power 8 in 1 plus x square minus x cube whole power 9. We know the binomial expansion for something like a plus b whole power n when there are two terms. Here there are three, but nothing to worry. We'll treat them as two. For example, this one as one and x square minus x cube. These two together as another one. A plus b whole power 9. And then let's proceed there. Okay, so now what is our binomial expansion? A plus b whole power n is nc0 a power n b power 0, nc1 a power n minus 1 b power n b power 1, nc2 a power n minus 2 b power 2, likewise. Total power n means there will be n plus 1 terms, right? From nc0 to ncn. What is tr plus 1 term? Tr plus 1 is ncr a power n minus r b power r. So there are total n plus 1 terms, and this is the term r plus 1th term. Right. Let us use this. Here in this case, our a is, let a be 1 and b is x square minus x cube. If you use this expansion, what will we get? 1 plus nc0. nc0 is 1, right? And 1 and 1 power 9 is still 1, right? Now nc1, again 1 power 8, so we can ignore. And x square minus x cube whole power 1 plus nc2. Right. Again, 1 power we can ignore. Then x square minus x cube whole square. Similarly, nc3 x square minus x cube whole power 3. Likewise, till nc9 x square minus x cube whole power 9. This is the expansion. But here we have to find what is the coefficient of x power 8 overall. Right. Now, this term when we expand again, it can give some coefficient of some x power 8. We don't know. We have to find, right? This also, if we expand properly, we might get some x power 8. Similarly, every term of this 10 terms, if some might give some x power 8s. What are those terms? We have to find, right? So what we do, let us take one generalized x square minus x cube whole power r whole power k. One generalized term, right? Because we have x square minus x cube whole power 1, whole power 2, whole power 3, whole power till 9, right? Let us take one directly generalized term, x square minus x cube whole power k, and let's see what does it make to get x power 8 out of this, right? This is again x square minus x cube whole power k is again in, we can expand this using our binomial theorem. This is still in a plus b whole power n format, right? What is the tr plus 1th term in this? What is the generalized term? Generalized term is kcr and x square whole power k minus r minus x cube whole power r. Right. This is still in a plus b whole power n formula. What is tr plus 1? It is kcr first term x square power k minus r and second term power r, that is minus x cube power r. If we just simplify this, we get kcr x power 2k minus 2r minus 1 power r and x power 3r. This minus 2r and this 3r we can still combine. So x power 2k plus r minus 1 power r and kcr. So this is the generalized term of this expansion, x square minus x cube. K can be 1, 2, 3, 4, whatever. K can go till 9. Now we want x power 8 in this generalized term. In the generalized expansion, we want x power 8. If you want x power 8, what does that mean? 2k plus r should be 8. Right, 2k plus r should be 8. Right. Now we also know one more thing is r is always less than or equal to k. Right. R cannot be NCR, r cannot be greater than n. Right. N is the r, k is the limit. So r is less than or equal to k and k can go till 9. Right. Because x square minus x cube whole power 1, 2, 3, 4, 5, 6, 7, 8, 9. It can go till 9. Now let's see where we can fit k and r together. K is anyway integer, r is also integer. If k is 0, will it work? 2 times 0 plus 0? No, it doesn't work. K is 1, 2 ones 1 plus 1 because r can be less than or equal to k only. 2 ones plus 1, 3. That will also not work. 2 twos plus 2. Total 6. That will also not work. 2 threes plus 2 will work, right? When k is 3, r can be 2. Then this equation will be satisfied, right? So 3, 2 is one set where 2k plus r equals 8. Now 2 fours, 8 plus R 0, that will also work. So 4 0 is another set. And anything beyond that, 2 5s already done, R cannot be negative. So 2 5s is already gone, or 2 6, 2 times 6, or anything. K greater than or equal to 5 is clearly not happening, and nowhere else. Between 0 and 5 also we found we have got only 3 2 and 4 0. What does that mean? Only in this cases x square minus x cube whole power 3, k is 3, right? Whole power 3, or x square minus x cube whole power 4. Only in these two cases we will be able to find some x power 8, only in these expansions. So whatever, basically x square minus x cube whole power 9 you can directly ignore. We can directly ignore all other terms also. The only terms that we should worry is when k is 3, that is nc3, sorry 9c3 x square minus x cube whole power 3, and 9c4 x square minus x cube whole power 4. Only these two terms we should worry. Now what is the overall coefficient of x power 8 in this? Then whatever this 9c3 and whatever the coefficient within this that we get in the expansion of x square minus x cube whole power 3, some coefficient of x power 8. What is that coefficient of x power 8 in this expansion? X square minus x cube whole power 3. That is this one only, right? 3c2 x power 2, 3 plus 2, this is anyway 8, and minus 1 power 3. Right, minus 1 power, sorry, minus 1 power 2. Right, 3c2 kcr, 3c2 and x power 8 minus 1 power 2. Right, 3c2, what is 3c2? That is this term, right? In this entire expansion, we will get one of this term, right? In 9c3 into 3c2 x power 8. Rest all, this expansion will have a lot of other terms, but those are not needed for us. We are concerned about only this term. This term will have one 3c2 coefficient, and this 9c3 is already there. So 9c3 into this 3c2. 3c2 is 3. This is one part of the coefficient. Then in again the next term, that is 9c4 x square minus x cube whole power 4. Right. There will also be one term which is to the power, which where x power 8 is there. Right. Obviously, what is that term? That is obviously x square whole power 4. Right. That is obviously the first term. First term only. What is it? 4c0. This one. 4c0 x power 8 and minus 1 power 0. Right. That is 4c0. This is the first term, right? Clearly, right? X square minus x cube whole power 4. Obviously, the first term itself is x power 2 plus power 4. That is x power 8. That is the first term. 4c0 x power 8. X square whole power 4. This is right. So, in x square minus x cube whole power 4, we are getting this term. Only this term, nothing else, right? Now, this is the coefficient 4c0. And what is the original coefficient? Coefficient before this, before the expansion, it should be 9c4. Right. So this 9c4 into 4c0. 4c0 is anyway 1. So this is coming from this term. This term. That is x square 9c4 x square minus x cube whole power 4. So we have these two coefficients. Right. The total coefficient is this plus this. One is coming from 9c3 x square minus x cube whole power 3. The second is coming from 9c4 x square minus x cube whole power 4. So the total coefficient of x power 8 is simply this. Right, guys? This is a very basic problem. We just used our binomial theorem only, but we used it twice. We used it twice in the expansion and found out the generalized term in the second expansion to find what is k. To find when this power can become 8. What is the condition between k and r? And we found it only two cases of this entire expansion. Only two places have the ability to bring x power 8. Right, guys? Hope you like this. Thank you.